Hi everyone, welcome back to Pareto Analysis channel. In this video, we are going to discuss about from the book called Six Sigma for Manager, written by Greg Brew. This book carry 10 chapters, 10 classes, 10 chapters, and we are going to discuss the final chapter called Six Sigma Proof Positive. The core theme of this chapter is to share the best practices which author wanted to share. There were 3 success story being discussed in this one, and I am going to discuss case study number 2. Wonderful success story, and you will have a lot of learnings in it. So it says that in a manufacturing company, and there were many defects and scraps were generated. The main issue is on the high rotating component, there many rejection were there, and the rejection due to stress induced in the component, and that cost 170k dollar per annum. And the project goal was to identify the variation and fix the process permanently and reduce the cost of poor quality. The cost of poor quality is beyond 10%, and it is 170k per annum. So the measure phase, what they did, first they did it control chart. In the control chart, they identified that there were many outliers are happening and many components were failing only because of the limit, because of the induced current and because of the leaky current and all that. And then GRR was being identified, measurement system analysis, and then they found that 17.5 variation in the smallest dimension component, and whereas in general there were 30% of variation is being caused. And then process capability was being determined, and process capability CPK value is just 0.18, which is correspond to 0.6 sigma, that is less than 1 sigma. So that means in the measure phase they concluded that there are too many variation, process is not capable, process is not consistent. In the analysis phase, and then in the analysis phase, very interesting, they did a Pareto analysis, what are the different causes, and then they did a Pareto analysis. In the Pareto analysis, they established the tooling pin established as a main underlying cause. That main underlying cause, again they try to fix it, and then they introduce a proper tooling pin in such a way that the component fixed on the PCB and there is no variation in the leads and the length and all that. So by that, in analysis phase itself, they identified that from 0.6 it rose up to 4.3 sigma. So that wonderful result they got it just by fixing the one of the root cause called pin variation, and they fixed the problem and they got one of the solution. And also they not only they just fixed that one, they also found out any other major deviations or deflections, and there also they studied in analyze phase. And improve phase, what they happen altogether, stiffer tool being introduced, a automated tool which will take care of the leads and the length and all that. Okay. And the last one is the control phase. Again, once again the control charts being done, and in that control chart the new slot, new design machine happened to be very precise, very accurate, and then sigma value it came up to beyond 6 sigma. So the conclusion is ultimately the final through yield increased from 28% all the way to 94%. And then secondly and final one, so the annual the cost of poor quality 170 was there annually, which is getting cost 170k, and now it is annually they had a saving of 309 annually 309k annually saving. So this is the conclusion. So in this one, the lesson to be extracted, number 1, always go to underlying root cause, fix that. Every problem we can fix that, every issue we can fix the issues, right. So first identify the root cause, number 1. Number 2 is collect as much as data as possible, number 2, and then determine the root causes and fix it. So this is the one such story which I would like to narrate to you. I hope you find this in such story very useful. I will be making much more videos, much more content in YouTube channel. Thank you very much. You have a wonderful day ahead.